Differentiations. Second lecture. Now I will write a basic differentiation formula. Basic differentiation formula. So all the results are obtained from first principle method. Okay. So d by dx of constant, c is a constant, equal to 0. Okay, c is a constant. C never changes, any constant never changes, so no derivative. No derivative means the answer is 0. Next, d by dx of derivative notation is d by dx or dash or capital D. Okay. Notation of differentiation is dash d by dx or capital D. Okay. So d by dx of x power n, it is n into x power n minus 1, n times x power n minus 1. N is any rational number, n belongs to Q. Next, d by dx exponential functions, a power x. For x power n, base is a variable, power is a constant. Okay, for exponential functions, for a power x, a is base which is a constant and power is a variable, x is a variable. Okay, it is a power x ln a should be greater than 0 and a is not equal to 1. Okay, if a is equal to 1, the function is not exponential functions. So d by dx of e power x. So e power x ln e is 1, so we write e power x. Okay. D by dx of natural logarithm, that is ln x, it is 1 by x. Okay, x should be greater than 0. X not equal to 0 and also not negative. D by dx of log x base a, that is 1 by x ln a. Okay, so we write log x base a as by change of base rule, we write it as ln x by, we change it to natural logarithm. Okay, we change it to natural logarithm by change of base rule. So d by dx of ln x is 1 by x. So we get 1 by x into ln a. Okay, so d by dx of ln x is 1 by x only, but d by dx of log x base a is 1 by x ln a. Okay. Next, d by dx of root of x. So we write root of x equal to x power 1 by 2. D by dx of x power 1 by 2 is 1 by 2, x power 1 by 2 minus 1, that is 1 by 2 x power minus 1 by 2. So 1 by x power minus 1 by 2 is 1 by x power plus 1 by 2. That means that become 2 root of x. Okay. So d by dx of root of x is 2 root of x. D by dx of 1 by x square 1 by x, not x square, that is minus 1 by x square. Next, we write the derivative formula for trigonometrical functions. D by dx of sin x, it is cos x. D by dx of cos x, it is minus sin x. D by dx of tan x, secant square x. D by dx of cot x minus cosecant square x. D by dx of secant x, it is secant x tan x. D by dx of cosecant x, it is minus cosecant x cot x. Okay, so all the results can be obtained only from first principle formula method. Okay, next we write the derivative for inverse trigonometric functions. D by dx of sin inverse of x, that is 1 by root of 1 minus x square. D by dx of cos inverse of x, it is equal to minus 1 by root of 1 minus x square. D by dx of tan inverse of x, 1 by 1 plus x square. D by dx of cot inverse of x, minus 1 by 1 plus x square. D by dx of secant inverse of x, 1 by mod of x into root of x square minus 1. D by dx of cosecant inverse of x. Okay, so we write minus 1 by mod of x into root of x square minus 1. Okay, these are all formulas. We must throw it, then only it is easy to handle the problems. Next we see the properties. Okay, properties of differentiations. First property is d by dx of k times f of x. Here k is a constant. Okay, we take k outside and differentiate only f of x. K is any constant. And second property, additive rule of differentiations, d by dx of f of x plus or minus g of x. So we write d by dx of f of x, differentiate separately d by dx of g of x. Okay, this rule is called additive rule of differentiations. Third one is product rule of differentiations. Product. Rule of differentiations. Okay, two or more functions are in product, we follow this rule. Two or more functions are in product, we follow this rule. Okay, first one is d by dx of, I am taking two functions and they are in product, d by dx of f of x and g of x. So first write First we differentiate f of x, that is f dash of x into g of x. When you differentiate f of x, take g of x as a constant, okay? Plus, next we differentiate g of x and consider f of x a constant, okay? So write f of x into g dash of x. Dash denotes differentiations, okay? F dash of x is equal to d by dx of f of x, or capital D of f of x, okay? Here dash is a notation for differentiations. F dash of x is equal to d f of x or d by dx of f of x. Both are same. D denotes derivatives, okay? If three functions, I'm taking three functions, f of x, g of x, h of x. Now all the functions are in product, okay? When you differentiate f of x, consider g of x, h of x a constant, plus differentiate g of x, consider f of x and h of x a constant, right, as it is. Differentiate h of h and consider f of x and into g of x a constant, okay? There are three terms we get. So f dash of x, g of x, h of x, plus, right, f of x. Now differentiate g of x, g dash of x into h of x, plus, right, f of x, g of x, differentiate h of x, we get h dash of x, okay? And going on. Similarly, if there are four functions, we get four terms, okay, etc., etc. Next rule is quotient rule, okay? Two functions are in fractions. We apply this rule. D by dx of f of x by g of x. Okay. First write, first differentiate this f of x, f dash of x into g of x. Right, minus, write g of x, differentiate, sorry. Write f of x, differentiate g of x, we get g dash of x divided by g of x the whole square. Okay. This rule is called quotient rule. Both the function f of x and g of x are in fractions. Okay. Fifth one is called chain rule. Chain rule. Here functions are in compositions, okay? Functions are in compositions. This rule is called chain rule. We take fy equal to f of g of x. Here f and g are in compositions, okay? How you differentiate? We write rule as dy by dx equal to, first to differentiate this function f, okay, f dash of g of x, okay? Again differentiating this g of x, that is d by dx of g of x into g dash of x, okay? This rule is called chain rule. Similarly, I am writing second one for composition functions. So y equal to f of g of h of x. Okay, here we get three functions are in compositions. So dy by dx equal to, first write, first to differentiate this f dash of g of h of x. Next to differentiate g dash of h of x. Finally differentiate h of x, h dash of x. That's all. okay, etc. This rule is called a chain rule. Okay. So now we will do some basic problem on differentiations. Okay. Take y is equal to x cube 5x square 3x minus 6. Find dy by dx. So in this sum we use the formula d by dx of x power n is n times x power n minus 1. So dy by dx equal to, in the first term n is equal to 3, so 3 times x power 3 minus 1, so we get 3x square. So phi is a constant, okay, k times f of x is, write k and differentiate f of x only. Similarly write phi here and differentiate x square. Differentiation of x square is 2x power 1, okay, plus differentiation of x is 1, differentiation of 6 is 0 because it is a constant, okay. There is no x term here, that is x power 0, 6 into x power 0, okay. So x power 0 is a constant polynomial, so differentiation of constant is 0, okay. So 3x square plus 10x plus 3. So next y is equal to x power 1 by 3 root of x, that is x power 1 by 2 plus sin x, okay. So dy by dx is differentiation of x power 1 by 3 times x power 1 by 3 minus 1 plus 1 by 2 root of x, okay, differentiation of root of x 1 by 2 root of x, differentiation of sin x is cos x, okay. Now simplify, so 1 by 3, and now this is 1 by 3 minus 1 is minus 2 by 3, so minus 2 by 3 is written as 1 by x power 2 by 3, okay, plus 1 by 2 root of x plus constant cos x. So y is equal to, next problem, y equal to x square plus 1 into x square plus 5. Find dy by dx. Okay, both are in product, so we apply product rule to differentiate. Here this is taken as f of x, this is taken as g of x, okay. The rule is first differentiate f of x, f dash of x, g of x, plus write f of x, next to differentiate g of x, that is g dash of x, okay. This is the rule to follow if two functions are in product. So dy by dx equal to, first differentiate x square plus 1, differentiation of x square is 2x, okay, 2 times x power 2 minus 1, that is x, okay, 2x, differentiation of 1 is 0, write x square plus 5 as it is, okay. When you differentiate x square plus 1, keep x square plus 5 as a constant, okay, plus similarly when you differentiate x square plus 5, then keep x square plus 1 as a constant. Now differentiating x square plus 5, 2x plus 0, so we multiply, we get 2x cube plus 10x, again multiply 2x, we get to 2x cube plus 2x, okay, so we get 4x cube. So adding the like terms, plus 12x, okay, and y is equal, next problem, y equal to x times sin x. Here x is taken as f of x and sin x is taken as g of x. Again we follow the same rule to differentiate. Okay, differentiating x. Okay, we use the notation also. First to differentiate, we write in dash. Okay, x whole dash. That means we next step we differentiate x. Okay, into sin x plus right x, differentiate sin x. Okay, next step we apply differentiations. X dash, that means we differentiate x value. Okay, differentiation of x is 1, so 1 into sin x. Sin x dash means that is a dash is a notation for differentiations. Okay, dash is a notation for differentiation. Next step we differentiate. Okay, x times cos x. So sin x plus x cos x. Okay, similarly y is equal to x square ln x. So in this problem take f of x square and g of x is ln x. This is a basic simple problems. Okay, now differentiate x square first, dash ln x plus right x square, differentiate ln x. Okay, differentiation of x square is 2x into ln x plus plus x square, differentiating ln x dash means differentiate, that is 1 by x. So we get 2x ln x, x square by x is x, that's all. Okay, then we apply now I am doing a very simple problem. Okay, easy to understand. Then y is equal, next problem, x square plus 1 divided by x square plus 5, find dy by dx. Here both the functions are in fractions. F of x is x square plus 1 and g of x is square plus 5. We apply quotient rule. So y equal to f of x by g of x. So dy by dx equal to, okay, right f dash of x, g of x minus right f of x, differentiate g of x by g of x the whole square. So this is called a quotient rule. Here we apply the rule here. dy by dx. So first differentiate, here f of x is x square plus 1 and g of x is x square plus 5. Differentiate f of x. So differentiation of x square plus 1 is 2x plus 0. Okay, write g of x as it is, x square plus 5 minus, write f of x. Differentiate g of x is x square plus 5, that is again 2x plus 0. Divided by x square plus 5 whole square. So dy by dx equal to, so we multiply 2x plus 0, 2x, we get 2x cube. So 10x, so minus 2x cube minus 2x upon x square plus 5 whole square. Here plus 2x cube minus 2x cube get cancelled. So 10x minus 2x is 8x by x square plus 5 the whole square. Okay. Next, if y equal to sin x by x, find dy by dx. Next problem. Again we apply a quotient rule to follow. Okay. Differentiate sin x. that is sin x whole dash into x minus right sin x differentiate x, that is the right hand dash, okay, by x square. Okay, in next step I am differentiating. This step I am differentiating. Differentiation of sin x is cos x into x minus differentiation of x is 1, so sin x into 1 by x square. So we get x cos x minus sin x by x square. Okay. Next, we do the problem for by using chain rule. Okay, for y equal to sin phi x. The chain rule is y equal to f of g of x. So dy by dx equal to, first differentiate f and then differentiate g of x. So f dash of g of x into g dash of x. Okay. Here f is sine, g of x is phi x. Okay. These are in compositions. So dy by dx equal to, first differentiate f. Okay. So f dash of g of x. Okay. We write g of x inside of this f dash. Similarly, write differentiation of sine is cos phi x. Next we differentiating phi x. Here g of x is phi x. Okay. Differentiation of g of x is g dash of x. Similarly, differentiation of phi x is phi. That is again differentiate this phi x dash. So cos phi x. Differentiation of phi x is phi. Write phi before this cos phi x. Okay. So phi times cos phi x. Similarly, we write another problem, tan of log x. Okay, here f is tan and g of x is log x. Okay, we apply chain rule. Differentiation of tan is secant square log x. Okay, write log x as it is. Okay, don't do anything with the log x. Okay. Again differentiating log x, okay, that is log x dash or d by dx of log x. Okay, log x whole dash d by dx of log x all are same. So secant square log x, d by dx of log x is 1 by x, so by x here. Okay, so y is equal to cos of e power x. So dy by dx equal to, first differentiate cos and then differentiate e power x. Okay. Cos of e power x is minus sin of e power x. Write e power x. Don't differentiate now e power x. Okay. Cos of e power x is minus sin e power x and then differentiate e power x. Okay. Then differentiate e power x separately. D by dx of e power x. D by dx of e power x is same e power x into e power x. Okay. Now write e power x first minus e power x sin of e power x. Okay. Next problem, y of sin of tan root x. Okay. So we apply chain rule. Dy by dx equal to, first differentiate sin cos of tan root of x and now differentiate tan root of x. Okay. So cos tan root of x Differentiation of tan root of x is secant square root of x. Differentiation of tan x is secant square. Okay, so we write secant square root of x. Don't stop. Now differentiate root of x. This is a chain rule. Okay. Differentiation of root of x is 1 by 2 root of x. So cos of tan root of x, secant square root of x, 1 by root of x is 1 by 2 root of x. Okay. So okay, we will see more in next video. Subscribe my channel for updates.
Thank you.
Thank you.